This is geometry. It's semester 2. And this is the second unit of semester 2 called Special Right Triangles. This is the first lesson. Its name is 30, 60, 90 Edge Leg Practice. This is all on creatormath.com. Make sure you're under the Geometry tab. Make sure you're following the table of contents. This instruction says copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. So going over these problems doesn't explain all the notes. That's why you got to have that part in your comp book. And on this one it says copy the following problems, but there's a lot of verbiage here. I would be okay if you just drew the diagram in too. That's going to be up to you. All right, and there are on this one quite a few problems, so you're writing them kind of small. This one has 9 problems on it. All right, so to me, special right triangles is the hardest subject within geometry, so I don't expect that this is going to come easy for you. I expect that you're going to struggle with this, and I'm going to do my best to explain it, and hopefully you have this video to go back and review. This one describes the triangle in words, and that makes it even harder. Given a right triangle, so we know one of the angles is 90, with one angle 30 degrees, the side length across from the 30-degree angle is 10. What is the length of the other leg connected to the 90-degree angle? So let's try to draw what they're saying here. First, we're drawing a right triangle, and it won't be perfect because we're freehanding it. We're putting 90 degrees into one of the angles. That makes this a right triangle. That leaves these two angles in question, and I drew it kind of at a smaller angle, so I know I'm dealing with a 30, 60, 90. So let's make this 30. If this is 30, this is 90, this has to be 60 degrees. So this is a 30, 60, 90 triangle, and we like this kind of triangle. We call it one of the special right triangles. And the reason we like it is because the side lengths play out in specific ratios, right? The ratios involve things like radicals, etc. So it's very difficult for students. It also involves a lot of algebra in certain cases, which can be challenging given the algebra background that we may have. So let's try to read through what it says. Given a right triangle, I got that much. With one angle 30, I got that. The side length across from the 30 is 10. So let's go across from the 30, that means opposite over here, and let's make this 10 long. Okay. What is the length of the other leg connected to the 90-degree triangle? So every triangle has 2 legs like a human. They're the ones connected to the largest angle. So this is a leg and this is a leg. So they're asking about this over here. They're asking about what is this length, right? Let's put a question mark there to say how long is this. So the other hard part about special right triangles is the fact that we need to know a pattern for these. For the 30, 60, 90, we have a pattern that there's a 30-degree angle here. The side across from it becomes x. The length of the hypotenuse of this triangle is always 2x. And the length of this side down here, the leg attached to the 90, which is the one they're asking about, is x times the square root of 3. Or they'll just say x radical 3, which is, of course, very confusing to me if I'm a student. All that means is we're taking the number that x is and multiplying it by the square root of 3. And if we type that into a calculator, right, just to kind of model that really quickly. Remember, you've got your calculator in your phone. Click on your calculator. Make sure to turn it sideways like this, and then the more advanced calculator pops up. So what is the square root of 3? Clear this out of here. The square root of 3 is square root, that's a square root symbol, or radical, of 3. The number is 1.7320508076. Because it's an irrational number, we don't say 1.73. We say square root of 3 because it's more accurate. So that's a little bit of a complication. Bear with it for the moment, and let's keep pushing on to see what we get. What happens here is we can work backwards, right? If this side is 10 and this is 2x, then this is going to be 20 over here. So those are the easier sides, because if this is x and this is 2x, this has got to be x times the square root of 3. Well, if x is 10 in this case, then this is going to be 10 times the square root of 3. Now, I'm not going to go ahead and multiply that out. I'm going to leave it. 10 times the square root of 3, or the other name for square root is radical. So we literally going to circle 10 times radical 3, and that's this number here. What is 10 radical 3? We'd have to put it on our calculator to find out, and we're not going to, but just so you can see one of them, 10 times the square root of 3 is 17.32. And that's how long this side is. This side is 17.32 long, this side is 10, this side is 20 long. And that's the beauty of the special right triangles. We can figure all this out without theoretically doing any calculation on our calculator, because we came up with 10 radical 3 for this one right here. All right, let's go to the next. Given a right triangle with one angle 60 degrees, so I'm going to draw my triangle in the same orientation every time. And you probably should too. Put the right angle down on the right, put the 30 degree here, and the 60 degree up here. So I've got a right triangle, I've got 60 degrees here. The side length across from the 60 is 15, so now I'm over here. This one's 15. What is the length of the side across from the 90? Across from the 90 is the hypotenuse. They want to know this one over here, question mark. Well, every triangle plays out the same way, right? We've got our pattern here. The pattern is this one. It says x here, 2x here, and x square root of 3 down here. Now this is going to be one of the hardest problems to solve because this side is equal to x square root of 3. We literally have to take the 15 and say that is equal to x square root of 3. So 15 is equal to x square root of 3. We're going to now divide both sides by square root of 3. It's going to cancel here. I'm going to flip the sides, put the 15 over square root of 3 here. Then we have to do something called rationalizing the denominator. We're not allowed to have this number down in the denominator with a radical sign on it. So we multiply this by square root of 3 and square root of 3. And I actually have a separate instruction on this. So part of me wants you to just push on and see if you can find the answer to this. This is going to be 15 square root of 3 over square root of 3 times square root of 3 is square root of 9. 15 square root of 3 square root of 9 is 3. 15 divided by 3 is 5. So this equals 5 times the square root of 3. That's the length of x, right? And if x is equal to this, and this side is 2x over here, correct me if I'm wrong, but I got to multiply 2 times this. So 2 times 5 square root of 3 should be 10 square root of 3. Multiply by 2. Okay, multiply by 2, and the 5 multiplied by 2 is 10. The square root of 3 just hangs out with it, and you get 5 radical, or 10 radical 3 right here. All right, let's keep going. Given the right triangle with, all right, so draw your same orientation. 30 degrees, 60 degrees. These are all going to be 30, 60, 90. Given a right triangle, check. 60 degrees, check. The length across from the 60 is 30. Okay, what is the length of the side across from the 30? Now they want to know this one over here, right? Question mark. So we're going to go through the same process. We're going to take the x radical 3, because that's this side here according to our pattern, right here. We're going to put it equal to 30. We're going to divide both sides by radical 3. This cancels. We're going to multiply this by radical 3 over radical 3, which is 1. You can multiply anything by 1, and this is called rationalizing the denominator. This is going to be 30 square root of 3 over square root of 9, which equals 30 square root of 3 over 3, which equals 10 square root of 3, because the 30 divides by the 3 to get 10 square root of 3. That's what this side is here, right? So this is what x is equal, and the side across from the 30 is x. So x in this case, or this length of this leg, is going to be 10 radical 3. Given a right triangle with one angle 30 degrees. So stick with the same pattern. Let's put the 30 here, the 60 here, and the 90 here. Not a very good triangle, but let's clean it up a little. We have a right triangle, we have a 30 degrees. The side length adjacent to the 30 degree angle is 12. And it says the side length adjacent is 30. It doesn't say leg there, so I really don't like this question all of a sudden. What is the length of the side across from the 90? But since they're asking for this, I'm pretty sure they're telling us this one is labeled as 12. But I would have preferred they said the side length, I would have preferred they said the leg length here. That's what I would have liked. The leg length adjacent to the 30 is 12 is really what they're telling us. Okay, so let's go through the same process. We know that the model triangle for 30, 60, 90, this side is x radical 3. We have a side 12, so we're going to take x radical 3 equal to the 12, and we're going to solve for x. Once we know x, we know this side's 2x, so we're going to multiply by 2, and we should come out with this answer. Let's see if we do. Divide both sides by radical 3. Cancel this out because it's 1. Multiply this by radical 3 over radical 3 to rationalize the denominator, which is 12 radical 3 over radical 9, which is 12 radical 3 over 3, which is 12 divided 3 is 4, so I get 4 radical 3 is the value of x. I know that this side of the triangle, again, according to my pattern, is 2x, and now that I have x, I can multiply 2 times 4 radical 3 and get 8 radical 3. At first, this is going to be very daunting. As time goes by, I'm hoping you see there's a pattern to it, and that's the brilliance of these triangles and why we as teachers love them so much as geometry teachers. Given a right triangle with one angle 60 degrees and the side length across from the 60 equal to 21, what is the length of the two other sides? Interesting, 2 other sides. Okay, so let's draw our triangle out. Let's build it the same way every time to help our brains. Let's put in the value they give us. We got a right triangle, we got 60. The side length across from the 60, that's over here, is 21. They're giving us the same problem every time. What is the length of the other 2 sides? All right, so we're going to do the same thing. Our pattern is this. Let's redraw the pattern up here. The pattern for a 30 degree, 60, 90 is x, 2x, and x radical 3. So we're going to take the x radical 3, put it equal to the 21, and we're going to solve for x, divide both sides by radical 3. So this should look very similar. And this is the hardest type of problem to do, by the way. Let's go ahead and just say times radical 3 over radical 3 to rationalize the denominator. 21 radical 3 over radical 9. 21 radical 3 over 3. 21 divided by 3 is 7. So x is going to equal 7 radical 3. So I know that this side is 7 radical 3. And this is going to be 2 times that, or 14 radical 3. And so they say 7 radical 3 and 14 radical 3. It's got to be this one. It'd be nice if they told us which was which, but I have both those answers, and the answer has both those. Wow, this is the first time they even gave us a graphic. Otherwise, we've been drawing our own graphic. Given the following triangle, what's the value of CB? Here's CB. Let's fill in 30 degrees. And just to reorient this triangle, I might redraw it for you like this. This one's 30 degrees. And this one's 60 degrees up here. The hypotenuse is 12. By reorienting the triangle, it's the same exact triangle, but I took it and I rotated it. By rotating it, it now looks like my model. My model says that this is x, this is 2x, and they gave us 12. So this one's going to be significantly easier. I'm going to say 2x equals 12. I'm going to solve for x by dividing both sides by 2. X is going to equal 6. So now I know this side over here is 6. And that's the side they're asking for right here. So done. So notice how much simpler it was when we didn't have to deal with that x square root of 3. That's the hardest situation we did right here and all the prior ones. So maybe they're going to give us some easier ones as we continue. Given a 30, 60, 90 special right triangle, that's what this is called, by the way. What is the measure of the side length across from the 30 degrees? They're just asking us for our model. Given a 30, 60, 90 degree triangle, this is x, 2x, and x radical 3. This is the model, the pattern that they all fall into no matter what size the triangle is, as long as the angles are 30, 60, 90. So they're saying, given this, what is the measure of the side length across from the 30? So go straight across from the 30, x. So now they're just asking us about the pattern. Honestly, I wish this one had been given before the other ones. Maybe these problems were originally made to be in a random order. Given a 30, 60, 90 special right, what's the measure of the length across from the 60? So now we're in the same one. Let's just look if this is the 60 here. Across from this is x times the square root of 3. That's it right there. One more. Given a 30, 60, 90 special right triangle, what is the measure of the side length across from the 90-degree angle? So here's the pattern again. I'm going to draw it the same orientation every time, and you should too. X is across from the 30, 2x is across from the 90 or the hypotenuse, and this one's x radical 3. So what is it across from the 90? Over here, 2x. So this topic is called Special Right Triangles. Please look at the notes, copy those into your comp book on the correct pages from creatormath.com under the Geometry tab. You're not going to just get these problems from seeing the problem. You're going to need those notes too as some background. And go ahead and put these problems in your comp book also. All right.